Welcome to the Pisa-Fees demo. In this video, we'll be showcasing our work on Pisa-Fees as proof of achievement for the Catalyst proposal. In this video, we'll be using Atlas to build and submit real transactions to the preview testnet and show the details of those transactions using the Cardano Scan website. So let's go ahead and get started. First, we'll be creating a Pisa-Fee position. This is done with the createPosition function, which needs to know how much Loveless will be locking in it, as well as information on the exchange rate of various supported assets. For the sake of simplicity, we'll just be using one test asset, which is here. And we'll also be using this predetermined exchange rate information. This was determined to highlight how Pisa-Fees can be used to make sure a user pays no Loveless in fees, nor gain any Loveless in change, thereby maximizing the Pisa-Fees functionality efficiency. So we'll go ahead and make this transaction. And there you go. We have a transaction hash right here for this newly built transaction, which we will look up on Cardano Scan. And as you can see, here is the transaction on Cardano Scan. And if you go look at this transaction, you'll be able to see how there was indeed a Pisa-Fees position created at the script address. Now that we have created a position, note that the owner can also modify it. We will showcase that here by simply changing the rate to our desired value. But before that, let us first store this transaction ID in a variable. To modify our Pisa-Fee position, we'll be using the function called modifyPosition, which needs to know the TX outref of the Pisa-Fees position we wish to modify and a function to modify the rates information. We will just be using this code to modify the position to our desired rates. Now, let us write the code to modify the position. And here is the transaction hash for the new transaction that will modify the Pisa-Fees liquidity position that we will also look up in Cardano Scan. And here is the transaction. As you can see, indeed the contract was executed and the Pisa-Fees position was modified. Finally, a user can interact with the Pisa-Fees position by depositing some liquidity to the position in return for having any Loveless transaction fees or min ADA deposits paid for by the position. We can do this using the fee swap function, which needs to know how much liquidity we'll be depositing, and it'll unlock the corresponding amount of Loveless to be used as fees or deposit. Before we move on, I should mention that I did modify the position's exchange rate again to set up the next example, particularly in order to make sure that the next example truly highlights the fact that it's possible for a user to neither lose nor gain any Loveless for fees or deposit if they utilize the Pisa-Fees functionality properly. As such, I have updated the transaction ID associated to the latest Pisa-Fee position UTXO, and all of the updated details, including the new exchange rate, is visible on the screen right now. Now, because the next transaction we will be acting as user Bob, before we perform this next transaction, we will be showing Bob's wallet balance to make sure that we keep track of how much balance, specifically Loveless balance, Bob had before and after the transaction. We will be doing this using this function. As you can see, Bob has this amount of Loveless in his wallet currently. We should pay close attention to this amount of Loveless and make sure that Bob's wallet balance does not change while he uses the Pisa-Fees functionality to perform his transaction. In this example, user Bob is sending some tokens to user Alice and expecting to have the fees and deposit paid for by the Pisa-Fees position. To do this, Bob also deposits some liquidity into the position using fee swap. So let's go on ahead and perform this transaction. And here we have the transaction hash for the transaction which is submitted that we can look up on Cardano Scan. And here is the transaction on Cardano Scan. If we look at the UTXOs here, you will see that indeed the Pisa-Fees position was used to pay for the Loveless fees and the deposit that was necessary to fund Alice, who we were sending a certain amount of test tokens to. In fact, let's verify this by asking for the balance of Bob once again. As you can see, the balance did not change from the previous result. Specifically, the loveless balance, of course, because that is the part that is paid for by the Pisa-Fees position. This demonstrates the fundamental aspects of the Pisa-Fees protocol. As an additional note, the Pisa-Fees script also supports liquidation of invalid UTXOs that may have been accidentally sent to the script address and therefore do not contain the proper data. Let's say Bob accidentally sends 5 ADA from his wallet into the script address. We will be simulating that flow using this transaction. Note that this UTXO that Bob sent is not meant to be a Pisa-Fee position and therefore does not include a valid datum. And so here we have the transaction hash. We will be looking this up on Cardano scan. As you can see, this is the transaction, and indeed there was indeed a UTXO sent to the script address, which of course, as you noticed, does not have a proper datum. Now that we have an invalid UTXO in the Pisa-Fee script address, we will just be storing the reference transaction ID and we will just be trying to liquidate it. The way we do that is using this liquidate invalid function. So let's go ahead and do that. In this scenario, we will actually be claiming back the UTXO as Bob. However, the liquidate invalid function allows any user to claim these invalid UTXOs. That is how the script is designed. So here we have successfully submitted the transaction, which we will be looking up on Cardano scan. And here it is. Here is the transaction that successfully reclaims the invalid UTXO back to Bob's wallet.